Thanks for coming, everyone. Even I'm surprised there's this many people. Robotics is a new technology. It's a technology that in about 20 years from now, you will look back on this day and say, that's pretty funny because it was new back then, and it'll be as common as just about maybe dish soap. It'll be very common. This title, Uniting Robotics and IT Testing, is really a little bit about robotics, and it's a little bit about an exploration into how we see the concept of having to test these systems, which is pretty challenging. It's an initial scratch at the surface. I am not a robotics specialist by any means, but I am certainly fast becoming one, and I'm certainly a specialist in IT testing. So let's move to the next slide. SogetiLabs, I'm a member of, and for those of you that are in SogetiLabs up there, spare us the moment. For those that are not, keep in mind this is a 120 technology leader. And in the latest meetings in SogetiLabs, I was pretty adamant and passionate about discussing robotics. Maybe the next slide. Now, Uniting Robotics and IT Testing, this is yours truly. I'm one of the technology leaders, and there's quite a few other technology leaders out there that share the opinion that robotics is a very important sector. Also, Sogeti, Gemini Group, etc. This is a very important topic. We have a Sogeti High Tech. You see a photo of me, yours truly. Below there, you see the Sogeti High Tech. There's a high tech division that works frequently with robotics, designed to disrupt. And like I said, since this is a scratch at the surface, I believe we can shoot for the moon in robotics. Even though we may miss, we might land among the stars. So we're not going to go here for a very technical discussion on robotics, but we are going to kind of, I hope, spark a conversation. If the audio falls out, I'll call right back. So let's go to the next slide. So I'm going to talk a bit about the growth of robotics and why it's even worthwhile talking about. And then I'm going to segue pretty quickly into some obvious testing challenges and what that means. And then I'd like to talk in the end a bit about what we mean when we talk about quality in relation to robots. And what we'll find is that that's really the context, because the word robotics in itself is a very misleading term, and that's kind of where I want to start, if you want to go to the next slide. Still, there you go. There's a couple animations there for you, Eric. So, I've even had some people in SogetiLabs, like a colleague to me, writing a lot about robotics. Next slide. And I've written recently a thing about testing robots called We Are the Robots, Test Us If You Can. I see when you go on the internet quite a lot of topics in robotics, and not anyone's really paying special attention to testing per se. So I looked here in this niche, if you will, not in the men's bathroom with a robot sitting next to me, but I did look in this niche, and I decided to kind of exploit it. And I happen to be quite old. For those of you that are older than 48, I apologize, but I'm an older person. Most of the people in robotics are younger. And I couldn't help but think about relating it to this band called Kraftwerk, which was very popular in the late 70s, early 80s. And these guys must be quite visionary. They're from Stuttgart, Germany, and they had written way back then songs about robotics, and they had written about very complex ideas of man-machine, which actually only in 1978, telegraphing 2014, and looking back to the term 1920, when the term robot is used, an incredible jump of technology in a very, very fast pace. Let's go to the next slide. Now, Gartner has this nice hype cycle of emerging technologies, and what you want to be doing is looking to the left. To the left, you see the innovation trigger area. Now, this is the area where you want to be if you're investing in technologies for the future. And the idea here is you should be investing in technologies that aren't yet even occurring or popular yet. And you can see that a little bit above and below, well, above the 3D scanners and speech-to-speech translation, you see mobile robots. That's a bit up to I can't point here, sorry enough, but, near the word expectations, almost at the top of the trough. Then it knocks over into the peak expectations. And this is also a safe area to bet on. But what I wanted to say here is that there's a lot of other technologies that are coming up and following, including, you might see down below, brain-computer interfaces and quantum computing. This is the kind of interesting things that need to be in place for computers to be interacting with robotic frameworks, where we'll be able to really see some pretty incredible advances in, let's say, we think within 20 to 25 years. Now, this is not too early to be talking about it, because as you can see, some are going to be even 2 to 5 years or 5 to 10, according to Gartner. And robotics puts itself somewhere more to the 5 to 10 area, which is not that far away. Next slide. Oddly enough, the term robotics starts way back in 1920. Karl Čapek, who's actually from a descent in Eastern Europe, so he wrote a dystopian story actually called the RUR, which was a kind of dystopian story of robots in a factory gone awry. Strangely enough, one of the very first, and he used the term robot. He's from the Czech, what would have been Czechoslovakia back then, and he was in fact a dramatist scientist, kind of like Isaac Asimov, guys like this, although he was even more of a scientist himself. When you consider then that in 1920 the term robot gets used, and robot is in Slavic word, basically meaning slave, by the time 27 comes along, and that was the original image you saw on the first slide, robots are making their way into movies and into the imagination. By 42, we formulated laws of robotics. And by the 70s, only by the 70s, that's 50 years later, we actually have industrial robots. In the 80s, 90s, increased CPU, smaller satellites, laser technology, etc. And by now, we have wireless, completely autonomous robots that can walk 9 kilometers an hour, run, in fact, and can do incredible tasks. Let's move to the next slide. Probably I had animations in here, but this format, so it won't have the same effect, but one of the more important kind of advances in robots was just this simple robot called Unimate, and it was, created around, around the 60s, and late 50s, early 60s, excuse me, and it basically just had a simple lever, and it had a way of working. Strangely enough, robots like this really are the major robots around that we use in industry. But if you'll go to the next slide, just keep your finger on that button there, Eric. We can see that in a short amount of time, those just using one example of robotics, which is a concept of degrees of freedom, where you can move a joint up, down, back, sideways, etc. Back then they had only, like yaw, roll, and pitch capable for the manipulator, but only a short amount of, 40, 50 years, we have something like this big dog architecture from Boston Dynamics, where this thing is basically virtually a mock-up of a horse or a camel, if you want to, a cross between a creature that can autonomously cover vast kilometers, carrying massive amounts of load. With it has a gyro, it has knees and ankles and feet, and it can even negotiate itself on a frozen lake and keep falling based on its sensors and pumps, and it's a very, very complex computer that it has with very complex code. Next slide. So, we're no strangers to this concept at SogetiLabs, and at Sogeti we write about these things. It's the fourth industrial revolution. This book covers an interesting aspect of this kind of this technology is plugged in. Eventually, there's no real there's a lot of questions that robotics brings up. One of the questions we're going to talk about here specifically is testing. In just a moment, the segue will come for those waiting. But one of the questions that robotics brings up, lots of them, is all kinds of legal questions and how these things will be implemented. Of course, as soon as flight was discovered, it was implemented very quickly in the military, and robotics is probably no exception to that. Next slide. A colleague of ours, Son of Spain, kind of comes with this idea, which I think is fair, that technology is coming more to a visible and an intelligent way, seamless in the Internet of Things. But robots are kind of unique here. They're not going to be invisible at all. They certainly are going to be intelligent. They certainly will be personal agents and very related to the human side of things. We're going to be using computer computers, it's really estimated that basically everyone on this phone will have a robot within 10 years, if you don't already. And these things will be pretty prevalent. So if you look at this in a technovision point, technovision is a way of looking at technology and grouping it. Looking at the SogetiLabs Gemini, the placing of robotics is kind of tough. It fits in the human experience side and the people side, because we certainly will be collaborating with robots. But robotics also really can be kind of taking
Hang on. We have comments that falling apart. Can we dial back a second? Can you restart from Technovision? See how we're doing?
Yeah, no, sure. All of us slowed down as well. I think if I talk a bit clearer, that would be better. So, placing robotics along this array of technovision, which is a way of looking at technologies from both Gemini and SogetiLabs together, of course, is that we see that robotics can't really be placed into one particular corner in a way, except for the possibility that possibly it's not an invisible infrastructure, as I mentioned. It certainly is a system. It will be thriving on data. It will utilize a lot of data. It is something where when robots reach an AI capability, I think you're moving the slides back.
Somebody's moving the slides back. Hang on. Not me. Really, it's not me. I thought this was an interesting webinar, so I thought let's liven this up a little bit further. No, here you go. Back to the slides. Please, somebody's pushing the slide buttons. Please don't push the slide buttons.
That's okay. Whoever's pushing it, maybe it's a robot. Anyway, basically, the robotics, certainly I place this in the U experience. We certainly have a collaboration with these kind of technologies, and this kind of thing is very important to know. Of course, these things are designed for digital, but they're also very physical as well. So robots combine mechanical engineering and electrical engineering, and of course, IT, computer science engineering, and that's where the testing gets very interesting. Next slide, please. So let's look at some of the testing challenges. This is an old look at the electromotor man back in 37, 38. What's funny about this is for the quality management of that system, where we would be testing it or checking its quality or looking at methods and processes, basically there's not too much different here than some of the more leading humanoid robots that are around today. There's motion sensors that they postulated. The thing about smoking maybe wasn't as politically correct back then, so that was enough of a hassle. There were shafts. What they didn't quite understand would be the actual software and computers running this thing. This was purely a mechanical thing. You see, you had external control cables, so it was remotely operated. Robots these days, robotics, even if they're not advanced walking robotics or if they're industrial robots, will either be running embedded software or they'll be running remotely or via like a Wi-Fi kind of hookup to some kind of server who's providing them data. This presents a lot of unique testing challenges, mostly in the setup of the labs in which we test. But more importantly, in the way that teams will be very multifunctional, cross-functional, and multidisciplinary between both the mechanical, or all three, the mechanical, the electrical, and the computing science engineers, among other things. Let's move to the next slide. So, I mean, at Sogeti, we're no strangers to testing. We've devised processes for testing software. TMAP is one. And of course, I would say that TMAP is a wonderful, wonderful process, and it describes setting up phases in testing, which you have to plan your testing, prepare, specify, execute, and complete. But this kind of testing, along with business-driven and the toolbox, it slightly falls short. And I kind of place it with the 1927 picture of the robot. We understand processes and how to test. Robotics would require this as one dimension. So this is certainly a valid dimension, TMAP next. A very important part is still the kind of thing you'll need to do when you test robotics. You'll need to check against specifications. But the thing is, it's not any of it's just a phased approach. It becomes very iterative, if not daily. Teams that work on robots at these robots become almost like children, right? I mean, everyone is working on one. Teams are working together for that one robot. Let's move to the next slide. So I think more we've vamped up as well with putting TMAP in an agile context, TMAP in Scrum. And there you see a Boston Dynamics walking robot, which is in the test lab suffering a 20-kilogram smash on its hip to see if it can keep walking. I don't think too many humans could do that. And the robot keeps walking. This robot is designed to walk on really rocky surfaces with its legs. Now you can see the kind of testing setups that are used. There's a combination of a physical setup, a grid, a walking area. There's IT, there's computers on the left, there's people watching, there's people moving. This kind of testing is in the moment. It's agile. It's beyond agile. The sprints are not 3-week sprints. They're day sprints. They're hour sprints. And experiments and testing is brought immediately back into the designs. So it's very rapid testing, rapid development. We move to the next slide. Of course, we have a new way of looking at testing, TMAP ASD. I'm not trying to wrap much marketing in here, but please go take a preview of this, Neil's Quest for Quality. And this is more of a human story of testing, or human testing, human-based testing. And I think that this more wide array of looking at testing, not only is just a way to check items or systems, this is more of where we're going to be meeting in this world of artificial intelligence, physical frameworks, hardware, and actual interaction with robotics. So here you see Asimo from the Honda Corporation, and it's walking along. He's going he's going quite fast here. This is still, and he goes around roughly 9 kilometers an hour, independent. You see his testing team behind him, the people sitting behind those desks, and of course he's being tested as we speak in that picture. Next. Please slide. So when you look at the testing of these robots, well, you kind of have to look at the type of robot you're dealing with. I mean, I've been showing you a lot of photos so far of simply legged robots. But believe me, the most robots are stationary. That's the most use of robotics in industry today. Of course, there's all kinds of other shapes and utilizations of robots. Wheeled robots were even used in World War II in military terms. The German Wehrmacht had loaded onto kind of little mini tanks and rolled them around. You see these kind of robots also being used in police situations to avoid any casualties. There's all kinds of other things. Flying robots, we're very understanding about drones these days, and swimming. I mean, to go a bit crazy with this, there's robots that can do all 3. So if any of you are Transformer fans, these kind of things are existing. It's pretty far-fetched, but some of these things can actually, like I said, fly, swim, roll, and do everything all at once. There's Asimo again. He's simply a legged robot. So let's stick with legged robots for now. Next. So you see the robots have quite a lot of interesting elements. They have effectors, which is usually either pneumatics or hydraulics or engines of some kind. They have sensors, so they know when they get data from their surrounding area. And keep in mind, they have something like, software. This is where my IT testing comes in mind. If I were to be on a robotics team, I suppose I could help with at least the third area. I'm not a pneumatic specialist. I'm not a specialist in sensors. I could learn that. But I certainly could test the brains of the robot, or perhaps this day, my brains need a bit of testing here today. What's interesting is that the Honda Corporation kept Asimo, that robot you see there, autonomous, a secret for 10 years. No one knew about these labs, these testing areas. And it's because they didn't want to get embarrassed with their failures. And also, it's because they wanted to make the Erato grants, which is interesting because with an aging population like in Japan, robots that have human interaction are going to become more and more important. Labor is very expensive. The population is aging over the years, not passing away, so we have a graying. And the Japanese government has a Japanese Science and Technology Corporation grant, so they give grants to big companies to do this kind of robotic research. So there's money in robotics. Next. Let's take a look at this interesting robot. Eric, you're going to have to, unfortunately, since I gave you the PDF, I have many more slides here for this robot. So you guys will not be able to see what I wanted to show you in my PowerPoint slide animations, but this is in fact Presto. It is in fact a perfect copy of an organic kangaroo, that's right. And Presto is an autonomous robot powered, you see he's not hooked. He has a very serious amount of 2 motors in his 2 legs. He has a motor in his tail. He has sensors. He has a kind of way that he can, when he lands on his tail, he can utilize that energy to push himself forward. He's remotely controllable with an armband, actually, so a device from the user who can move left and right with the hands and spin around, and this robot will react. This robot is a pretty nice kind of way of looking at robots in a simple way, moving robots, because they're a nice combination of all kinds of elements, as I said, the mechanical, the electrical, and the IT. It's really hard also not to eventually start associating on these kind of things. When you look at an actual kangaroo, that's very different, of course, but this thing, when you see it in motion and what it does and how it reacts, it's very hard to imagine it isn't sentient, even though it's a very, very simple robot. And I was going to show you the elements and parts of this robot, and to show you how those things might be tested. Keep in mind that the materials themselves are very lightweight, those have to be tested. So the main thing I want to get across here is that in order to put this kind of robots together, you find a design, and in this case, nature created the design, the kangaroo. You work your way into that kind of design, and you test along those specifications. So the context is very important, of course. Now you might say, why do we need a kangaroo robot? I myself find this to be rather interesting. I have a sense of humor, and I like it, but this happens to be one of the most very effective robots I've seen as far as movement. Maybe the kangaroo is also looking forward. No pun intended. Next slide. Here you see some of the slides I wanted to show you. You see motors for its hips, you see the valves, you see
Hang on, you're losing audio again. We need to dial it back a little bit. So you're talking about the armband and...
Yeah. Okay, I'll continue from there. I'll slow down. Sorry, it must be the solar flares we're having. I'm assuming now that you can hear me again.
Yeah, I can, but I think we're good.
Well, if you can't, then generally they would. The point that's to be made here is that the way that we'll test these systems and have to test these systems is gradually, very iteratively. It's as if the different versions, like if you were testing software, if you were testing this version of this robot, you have to go through an evolution in itself. Okay, let's go next. Yes, the sound's going to go in and out.
Yeah, the sound is better. I think the sound is better now. Also, I disabled my fully automated backup solution to the cloud from uploading a couple of gigabytes while we were doing a webinar. So that maybe helps too. So keep going.
Yeah, maybe we'll just avoid doing the bandwidth. Sorry for any challenges in audio, folks. Quality robots, what's the context? Let's take a look at some context and how that affects the testing and the quality we test for. Next slide. So strangely enough, that robot you see down there is that same dog robot from Boston Dynamics, but here it's in a combat testing context. It's carrying a bunch of ammunition and medical supplies and food for soldiers. It is also very loud. In fact, it's run with a fuel engine. I don't know why these soldiers would want to be in a field with this thing if they were doing some maneuvers which required them to be stealth. But anyway, there's industrial robots, domestic and household robots, medical robots, quite a lot of robots. And in fact, just recently I saw the robot gift list for 2014 where it's basically just hobby and fun. So it's these contexts that you test in, of course. these military service robots are going to be tested not unlike you would test a weapon system. But of course, entertainment robots, those are the Japanese, are very quite good at this kind of stuff. They even have robots that talk to students and might become, replacing teachers and things like this. These things are designed and tested for soothingness. They're tested for psychology, for interaction, for the look of the robot, for the voice it uses, all kinds of interesting things. So the robotic testing field is really exciting in that sense because it combines all of these sciences and a lot of psychology. It's a lot more dynamic than testing just the software aspect, believe me. Let's go a bit further. What robots do is they do the 3Ds, the dirty, the dangerous, and the dull work. But what I think is some people might think that robots are depressing, or it might, they do the demanding work. But I think that robots will be doing daring and dynamic work in the future, if not very interesting stuff, very human stuff, interacting with people. Maybe you saw the situations in Paris. Maybe it'll be robots who will be helping to go in and take out bad people, or maybe it will be robots that will be helping us in the store, or helping us at the hospital, and this kind of thing. Okay? Next. So, I'm not going to go into, since this is about testing, I'm not going to go into are robots good or bad, although that's a really fun discussion. Certainly, Osmo, a step in mankind's ongoing advance. Is it something like here you see the I don't know if you saw Interstellar, but there's an incredible robot there in the film that plays a key part. This is a very interesting robot rover on Mars, which is still working for humanity out there, finding stuff. There's lots of incredible technological advances. Testing this kind of thing would require the sciences backing up what those things are recovering. So, you're not only going to have mechanical, electrical, and computer engineers testing this, you're going to have biologists and physicists and scientists programming to look for certain signs of life or certain things. These robots have spectrometers. They have an incredible way of looking at the world. This is a wheeled robot, this rover. Of course, they don't always work as expected, of course, but they go to other planets even to talk about context. Or, next slide. Oh no, sorry, there's no board. Board will come after. This is just an example of IEEE Spectrum. I put it on because IEEE Spectrum also shows other contexts of robots quite a lot. If you ever go to IEEE Spectrum on the Robotics website, I recommend it because they talk about robots that do anything. Robots that draw drawings in the beach for you. Robots that will do our sports for us in the future. Robots that will do our laundry. Robots that will be our friends, robots that will go to school with our kids. We have also kind of replacement robots, or robots that are your parents watching you while you're gone with a little screen that roll around and follow you around the house when they go out to the store. Next slide. You've got a kind of friendly Toshiba Android there. You see it's a very human, lifelike thing. You can practically not tell the difference between her and a real person. Actually, of course you can once you start speaking, but you see there the suitable technologies for staffed. You see a store that's staffed only by robots there. Fourth from the left. You see a robot down at the very bottom that can pick up a very small ball bearing, utilizing very special materials and its finesse. And of course, Amazon is using robots to pull their inventories from their stacks and keep up efficient ways of sending packages to your home. Robots are everywhere now, and they're going to be even more everywhere in the future. So then that's the or. I believe the next slide. Sorry, I didn't. Or are they indeed Asimov's step in mankind's obsolescence? I seriously think they're not. But of course, if we have robo-hackers in the future or lack of common sense, of course, this is where the technological challenges for testing is going to have to rise. We're going to have to make sure when we test in the quality of these robotic systems that the potential tampering or misuse of these robotics shouldn't occur, just as we need to test this for smartphones, or we need to test this for mobile devices or Internet of Things. These things will be very special things in the Internet of Things, so they'll be even more apt or prone to have a direct impact. So they need to be tested even more thoroughly. Next. that's where the robot started, that little arm back in 1958, 51. And now with Keller and Knopik and Augsburg, this is Achilles, the world's fastest robot, which is programmed to play a match against this guy, Timo Boll. And I recommend you go to YouTube and check it out. And I won't tell you who wins, but this robot is incredible with its artificial intelligence and how it plays against this guy. Next. What's interesting to switch to AI is, let's talk about robotics, but artificial intelligence is where it gets really interesting. This is a still shot from Blade Runner where Rutger Hauer's character actually is smarter than the people who made him. Now, what's always weird is we're taught in testing with black box that we're taught, there's an input, there's something going on hidden, and there's outputs. But with AI, they take two approaches. There's like the top-down. You build the brain first and you start trying to make this robot think, and then you're going to control its units, or you start making the framework of the robot, making its code, and don't worry, it'll be a collective brain eventually. You could argue that we as humans went through evolution to have our brain working a certain way. So I don't know if you've ever been tested. We do tests when we go to high school, or what to show our tacit knowledge or implicit knowledge or explicit knowledge. But robots, when we move to a door, we use 260 muscles. We walk, we see the door, and we make calculations, and we do it. Robots need to be told to move all of those 260 muscles. They need to be told to open the door, and what that means, they don't conceptually or tacitly understand yet. Where artificial intelligence comes to mind, is a misunderstood word, is where these robots and these robotic systems will be able to, in a kind of cognitive trick, understand what they're doing and learn. Next slide. Where this gets a bit weird is because we start getting into the science of neurology, information theory, symbolic manipulation. What's interesting is that when we see people, we do, with our utilize our senses, our eyes, our ears, we recognize, oh, that's Daniel talking, that's Eric von Olmeren talking, great. We use perception. Well, robots will have a much more perceptive spectrum. They might be able to see in infrared, in normal light, in ultraviolet. They'll have a much more incredible world to live in. Their logic will be a lot more based on neural networks, electronic neural networks. But if you're into any of these things, this is also where testers will need to come from. People who have ideas and learning in mathematics and in psychology and cognitive logic and in cognitive programming. And so this kind of stuff in languages and this kind of stuff will be very important for people testing these AI systems. Next slide. There's lots of research labs already doing this. Here's a few that are mentioned, and if I don't mention one from one of your countries you're in, I'm very sorry, because just about every country now. One. This is Petman, by the way, from Boston Dynamics. It's their answer to Asimov, and I can swear when you see this particular robot in his test frame, there he is in his test frame with his tester sitting behind in a kind of test bed. He looks human. You almost want to say, okay, you can take off the uniform now. We know there's a human underneath there. What's kind of scary is Boston Dynamics is one of the companies bought by Google, one of the top 10 companies bought by Google recently, and that is a biochemical suit that he's having. I don't think robots will be concerned about mustard gases or xenon gas or diseases for that matter. So robots will be able to do quite, as I said, the dirty and the dangerous stuff. So it's interesting that this robot's being tested with that particular uniform set on. Next slide. Sorry, next slide?
Yep, we're going.
Okay, so let's conclude by saying that robots have quite grown. Next slide. It's come a long way since the robots of Japek, and this is a guy, Christian Dehamer, who says basically that Bill Gates even believes in robots, and that Bill Gates claims, none other than him predicts by 2025 robots will be as common as computers. That's not too far away. In the U.S., robotics is already a 1.35 billion industry, and it's a 20 billion industry globally. And so personal robots are expected to be around 15 billion soon, 70 billion by 2025. Next slide. to show a couple stats. This is the classic thing where we end trying to impress you with stats, but military spending is where it's originally starting, but eventually it's going to be industrial, commercial, and even you'll see the personal down at the very bottom of the last five. I would even be willing to guess that that's a guess, and that I think personal robots will grow quicker as personal computing also grew quicker than we probably thought. Next slide. You'll see that here's some of the major names of robotic companies on the left, including Google having Boston Dynamics and all the other companies it has. Amazon is there, iRobot, quite a lot. Anyway, the growth here is showing that the traditional players versus actually positioning for new leadership in robotics in 2013, 2014, and that's growing quite immensely. So this is certainly no area that is planning on stopping. Next. And I think I round off. I myself am talking at one day in Agile Testing Day soon on the 19th of March. We are the robots agile testing for the future, so something I'm keen on talking about. And the next slide is just simply the ending slide, opening to questions. Again, I'm sorry for the audio. I hope this was an interesting topic for you guys. If not, in SogetiLabs, there's all kinds of very interesting topics, downloads from the Internet of Things, research that SogetiLabs has done, and events that SogetiLabs has planned in the future, and I'm sure robotics will play a part in that.